So I mentioned that we're going to get going on the bridge structural arm that's going to kind of arch across the entire bridge, and we're also going to do the roof that kind of flares out at the ends. So in order to generate that structural armature, I need to first find a particular point somewhere to begin it. And unfortunately now I need to go find that bridge again so I can show you. I didn't save the picture. It was somewhere in one of these images that won't load.
No, that one.
That wasn't it. This one. All right. So, so this structural arm, we're actually going to anchor it to the side of the building, and then we're going to sort of build it outwards. So I need to find a point here, sort of somewhere in here, to start building my geometry. And if you think about developing the thickness of that geometry, it's very similar to the guardrail form itself. I can do it a bunch of different ways. I could start with a point, develop the arc. I can offset the arc up and down. I can create a surface and extrude it. And then I can just copy another copy off to the other side, something like that. So I'm going to try and just simulate the same process and keep it simple, keep doing the same thing that I've been doing the whole time. All right, now, so it's pretty much exactly the same process, but I think the only thing that really changes here is how do I find that control point? So what do you guys think I could do to find a control point on this surface and start developing that geometry? You're kind of on the right track. We will need DeconstructBrep at some point, but I mean, there are a few ways of doing it. I could grab like this point that's right on the edge, or I could try and find a center point for the geometry in here. I think since this point right here is sort of on the edge and it's roughly halfway across that point, I'm going to try and just find the midpoint of this edge of that volume. Okay, and I'm going to use that to start generating it. Secondarily, I'm going to just need to generate a curve from one side to the other and then move it upwards. So let's jump back into it. So first things first is I need to find that edge. And this is something you guys haven't done yet. It's actually a poly surface that I'm going to deconstruct, and then I'm going to isolate it one edge out of all of them. So let's see, that was the old one, or yeah, this one right here. So if you guys care at all about your naming conventions, you might want to create like a named thing here, but you don't have to. Anyway, I'm going to go to Surface, Analysis, and DeconstructBrep. And this breaks that whole thing apart. And now you know, at this point now, you should all know how to isolate certain items in a list. Well, all those edges can be isolated. So I'm going to go to Set, List, List Item. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges in this whole thing, and you'll see them all here. 12 locally defined values under edges. That's good. So I can do a slider from 0 to 11, because I'm not sure which one it is yet. So I plug that into I plug my edges into the list input, and now you'll see that index item 0 is that curve that arcs across on the inside, the bottom inside edge. But as I move it across here, it will pick different edges until I find the one I want, which is that one. You guys understand that conceptually? Yeah, easy enough, right? Well, I'm going to need two of them. I need the one in the middle, I need the one on the other side, and I'm going to need one, actually, I think I just thought of a better way of doing this. I did. All right, I thought of a better way of doing this. So we're going to need this, but we're not going to need it yet. So I'm just going to kind of, whoops, I'm going to pull it off to the side. So rather than trying to reconstruct the arc, that's what the road I was heading down. I was going to reconstruct an arc using points across this surface. But rather than doing that, I'm going to use my domain reduction, and I'm just going to reduce that surface by half so that I can, well, here, I'll just show you. So I'm going to go to faces instead, rather than edges. And so that is, let's go back here. That's the inside face, bottom face, edge face, that face. Okay, this is the one I want. I'm going to reduce the domain so that it just goes down to halfway and gives me the arc. That's easier. So I'm going to go to Math, Domain, Construct Domain Squared. And you guys all know that when you're doing a percentage reduction, we're going to need Surface, Utility, and Isotrim. And that's going to have to be reparametrized. So I think every single one of you, when you go back and start doing this on your own, you can sort of just follow along and do it exactly the same way. I don't think we have any deviations yet. So 0 to 1.00, make 4 of them, and plug them all in. That one's going to be 100, or 1. That'll be, yeah. So notice here how it's kind of a reduction like this. Well, I just need to make sure that this is exactly 50. Oops. And that gives me not 50, 0.5, sorry. That gives me a half surface. So I need to do that list item again, but this time it's only a quadrilateral. So I'll copy paste, put that on the end, and then switch it to edges and grab that curve. There we go. Yeah, see? Easier, right? Than trying to do points and subdivisions and all that other stuff. So all you had to do was deconstruct this BREP to get the surface. That was this. Then you reduced the domain, and then you deconstructed that, and then you found that edge. So it's just kind of rolling it over and over. Yes?
So I don't know how to think about this, but okay. So the Archie thingy, that's already its own entity, and then you decided to like get the surface, right? That's what it kind of is. To get that curve. Sort of.
I don't know what you mean by Archie thingy. You mean the guardrail volume?
Yeah, there you go.
Guardrail volume? Yeah, that's its
Yeah,
own thing. So I used that guardrail volume. I isolated the outside face. I reduced that face to create an edge that cut it in half, and then I just grabbed that edge.
Oh.
Yeah.
What happens if you change now the size of the guardrail? Is it still going to be the midpoint?
The size of the guardrail. Yeah, it will. So if I change the size of the guardrail now, that's why this is kind of nice to do it this way.
Okay. Yeah, because I was thinking.
It's going to follow.
Why wouldn't it just be easier to just go into Rhino and just get the midpoint that way?
Yeah, because if you change it, right? And so one of the things that I'm kind of leading you guys towards here is I'm going to give you guys a design change later that at the end of this, once we build this bridge, I'll give you a design change, and then you're going to say, oh, I get why I would want to do this in Grasshopper versus Rhino, right? Because it would mean you have to totally remodel it in Rhino. But anyway, so that's our curve, and real quick, I just want to keep it in the same thought here is, you know, how do we actually generate that volume? Well, all of those variables that we started defaulting, right, like our base normals and stuff like that, we can use that again. So what I'm going to do is make a copy of this curve, right? I'm going to kind of copy it off of this surface and then inside of the surface, and then, you know, just do some extrusions and stuff like that. But before I do that, I need to make sure I get the proper structural arm height. So I need to change my midpoint of this. So I'm going to reconstruct this. Let me go to Curve, Division, and we're going to do Divide Curve. We'll plug that in there. It defaults to a rather high number. I actually only want 2 divisions, which will give me 3 points. So that's 2, like that. Oops. 2 divisions gives me 3 points. So my task is to move just the center point. So I'm going to, you know, kind of keep recycling this list item and grab the one I actually need. So I'll go list item. I can copy this, plug that into I, and I happen to know that the one I'm going to want is index 1, right? Because in a 3-item list, the one that's in the middle is going to be number 1. So that's the midpoint. What do you guys think I need to do to move it?
Extend, no, extrude.
No, just move. We'll do the extrusion later. Yeah. So, and notice how this is a really linear thought right now, guys. It's like super simple if you just think of it step by step by step. But move is just going to tack right on to the end. But what's cool about move in this case is that this is kind of a structural reality in a way. Like the fact of the matter is we are moving this geometry in the z direction no matter what orientation this bridge has. So this is an instance where using unit z is appropriate rather than a referential like surface normal or something like that. Okay, so I'm going to use under vector, I'm going to use unit z and then put a slider. I have no idea how far up I'm going to have to go, so I'm going to say 0 to 50. Plug the geometry in, that's that, and then plug this in here and just yank it up. Let's see, we'll go something like that. Okay, now it doesn't look like much now. That's because we haven't reconstructed it into anything. So what I'm going to need to do is use this list item and grab my other points. You guys have reconstructed curves before, but I'll just copy and paste and put one up there, paste and put one down here. Make this my index 0, that's the first item in the list. Make this my index 2, that's the third item in the list. And then I've got point 1 right there, point 2, or I should say point 0, right, because it's index item 0. That's this one. And then point 1, and then point 2. That's that one right there. So we can just go back up into curve, use primitive, and then we can do arc 3 point, and just start plugging them in. We'll go from index item 0, 1, and 2. And there's our arc. Making sense so far? So we did a whole lot of deconstruction and element isolation. That was all of this, right? And then all of that was just to get these 3 points. Okay, so it's a little bit of a roundabout way, but the cool thing is all that geometry, I just turn it off. I don't need any of it. And what I'm left with is just that. Okay, so I'm going to stop this video where it is, and then we'll just keep rolling, and I'll get you guys out here fast.